Hi children, today you are going to learn ninth class. First chapter, it is a real number in that exercise number 1.2. In this 1.2 exercise, we are going to be discuss that about some of the questions either identifying rational numbers or irrational numbers and writing an irrational numbers between two rational numbers. How many irrational numbers are not how many rational numbers can be written in given two numbers. Suppose two numbers are given. How many rational numbers can be written between the two numbers? Suppose here 2 is a rational number, 3 is a rational number. How many rational numbers can be written between 2 and 3? Between 2 and 3 we can write infinitely many rational numbers. How? 2 and 3, there will be no numbers between 2 and 3, no? How can we write infinitely many rational numbers here? See, 2 after 2.01 I will write, or not 2.0001 I will write. Okay, 2.102 I will write, 2.321 I will write. Like this, I can make infinitive decimal numbers. I can write infinitely decimal numbers between 2 and 3. These all are 2 only. I don't go for 3. After 2 only I can write infinitely many decimals. Suppose 2.5637 327568. Okay, and then I start it. That means this value is 2.5 only. Again I did not go for 3. So you might be understood now. Between 2 and 3, that means between any two rational numbers, we can write infinitely many rational numbers. These are the decimal numbers. How can we consider these are as a rational number? As I told you, these all decimal numbers are terminating decimal numbers, because after the decimal point, the number of digits are countable here. So this was called as a terminating decimal number. Every terminating decimal number can be represented in the form of p by q. We know it. Suppose 2.01 can be written as 201 by 100. After the decimal point, there are two digits, so we put 2 10 into 10, that is 100. Like this. So between two rational numbers we can write infinitely many rational numbers, and between two given numbers, between these two numbers we can also write infinitely many irrational numbers also. Not only rational numbers, between these 2 and 3 we can also write infinitely many irrational numbers. Suppose this is A and this is B. Under root of AB form, this is A is 2 and B equal to 3. Under root of AB is a formula. Under root of AB is a formula to find out the irrational numbers. Suppose under root of 2 into 3, that equal to under root of 6. Root 6 will be between 2 and 3. Root 6 is greater than 2 and less than 3. Then you take these two numbers. These two numbers also. See, between, now it will be A equal to 2, B equal to root 6. Let's go for under root of AB formula. Under root of AB formula in the sense under root of 2 into 6. Under root of 2 into root 6. This 2 is outside. Will go for the inside of this. That means root 4 value will be 2. If 2 is coming the inside of the root, it will be a 4. So it will write under root of this 2 is coming inside of root. Now I will write 4. This root 4 value will be 2 into 6. That will be under root of 24. 24. And this 24 also will write like this now. This is what first one. Now 2. Between these two we have written now. So I will write like this. Under root of 24 is less than root 6 is less than 3. Now you take this is A and this is B, and also you go for AB formula. Like this infinitive number of times you can do this process. Hence between two rational numbers we can write infinitive rational numbers, infinitive irrational numbers also. Not only infinitive rational numbers, but also we can write infinitive irrational numbers are also. Under root of AB is a formula for to find out the irrational number between two rational numbers. Or else there will be one more process for this. See here. Here 2 and here 3. These two numbers are given. This 2 can be written as root 4. This 3 can be written as root 9. Yes, between root 4 and root 9. Under root of 4 value is 2. Under root of 9 value is 3. That means same numbers are written here. Between 4 and 9 we have again root 4 is greater than root 5. Okay, is less than root 6 is less than root 7 is less than root 9. That means this is a 2 is less than root 5 is less than root 6 is less than root 7 is less than 3. Root 9 value is 3. See, between 2 and 3 I have written these three irrational numbers. Again you take this is A and this you take as a B. Again you continue like that only. We'll be getting infinite number of infinite number of irrational numbers. So this will be constant. These kind of questions we are going to do it in the exercise number 1.2. The exercise number 1.2, this is what we are going to do it. Okay, then we go for the exercise problems now. Already we know, we have learned what is rational numbers and what is irrational numbers. In 8th class already we have learned that what is the perfect squares and square root numbers. Up to 30 squares and square roots we have learned in our 8th class itself. So that will be help us here to do the first question. Root 7, under root of 27. This is square root of 27. Square root of 27 is square root of 27. Classify the following as a rational or irrational. It is a square root of 27. It is an irrational number. Why it is an irrational number? Because square root of 27 is not a perfect square root number. The perfect square root number is under root of 25. Under root of 25 can be written as root 5 into 5. So one of the number will be a answer. That means square root of 25 value is 5. But the square root of 27 is not a perfect square root, so it is an irrational number. Not perfect square root numbers are called as a irrational number. Suppose if it is a cube root of 27, this value will be 3. Why cube root of 27 value is 3? This 27 can be written as cube root of 3 into 3 into 3. This can be written as 3 cube. Then cube and cube root get cancelled. We get answer as a 3. So 3 can be written as 3 by 1. As 3 by 1 in the form of a p by q. It is a rational number. But it is given square root. It is not a cube root. It is a square root. Here it is a square root. Here it is a cube root. It is the fourth root and fifth root. It will continues like that. Okay. It will be continuous like that. Then we go for second one. Square root of 441. Square root of 441. Is it a rational number or irrational number? Can you tell? Suppose you do it 21 into 21, what you will get? See? 1 into 21, 21. 2 into 21, 42. See? 1, 2 2s are 4. So 2 plus 2, 4 and 4. 441. That means it can be written as under root of 444. Square root of 444 can be written as 21. So 21 can be written as, this can be written as 21 by 1. So it is a rational number. Why? Because it is a square root of 441 is a perfect square root number. Perfect square root numbers can be written as in the form of p by q. So they are rational numbers. How to know the squares and square roots, cubes and cube roots? I have done the videos of in the 8th class. If you go to the playlist, in my videos, then you go for select a 8th class. Then in the 6th chapter, in 8th class 6th chapter is squares and square roots, cubes and cube roots. There I have explained all the squares and square roots. You can go through that. Or not, you can download from the internet and you can learn what are the perfect squares and square roots, cubes and cube roots. It will help us here. That's why I told. And here the third one is 30.23 42 345 and so on. So what is this number? Now this number is See, after the decimal point, the digits are not repeating continuously. 2 3 2 3 again 2 3 2 3 came, but again it should be 2 3 here, but there is a 4, later 2 3, then 4 5. It will be unsequenced number. There is no sequence in the number. There is no number is repeating continuously. So number of digits are uncountable, number of decimal digits are uncountable, and the numbers are not repeating. So that means the number of decimal digits are uncountable and these digits are not repeating, and this is decimal number, this kind of decimal numbers are known as non-terminating, not repeating decimal numbers. The non-terminating, not repeating decimal numbers are known as irrational numbers, because we cannot write in the form of p by q. Irrational number. Then we go for fourth one. What's the fourth one here? See, 7.484848 and so on. 7.484848 and so on. If you see clearly here, it can be written as 7.48 bar. It is a non-terminating repeating decimal number. See here, 484848. It is repeating continuously. The 48 is repeating infinitive number of times. So this is a non-terminating repeating decimal numbers. As we have discussed in the decimals video, that non-terminating repeating decimals can be represented in the form of p by q. So it's also learned that how we have to represent in the form of p by q in the exercise number 1.1 we have discussed. So these numbers can be represented in the form of p by q. So these numbers are known as rational number. It is a rational number. So next we go for fifth one. 11.21324 354 65. So see that it is a terminating decimal number or non-terminating decimal number. It is a terminating decimal number. How can you say it is a terminating decimal number? Because of after this decimal point, these decimal numbers are countable. See, decimal digits are countable. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. After this decimal point, there are 10 decimal digits. It is a terminating decimal numbers. All terminating decimal numbers we can write in the form of p by q. So if you are able to write in the form of p by q, it will be considered as a rational number. It will be considered as rational number. The last one of these bits, that is sixth one, 0.3030030000 and 3, we know that 4 zeros will come now. So see here, what kind of decimal number it is? Terminating decimal number or non-terminating decimal number? It is a non-terminating decimal number because here there are infinitive decimal digits are there. Okay, if infinitive decimal digits are there, then those decimal digits are repeating or not repeating. Here the decimal digits are not repeating continuously. See, here 30, here 300, 300, 3 4 zeros will come. That means a number is not repeating sequentially. Misorder is there. If 30303030, it will be like continuous like that. It may be a non-terminating repeating decimal number, but it is now non-terminating not repeating decimal number. So it will be considered as a irrational number. It will be considered as an irrational number. See that clearly, as we have discussed these 6 out of 6 as here. First one is a irrational number. The under root of 441, it can be written as 21 actually. Root 441 equal to 21. It is a rational number. And third one, it is a non-terminating, not repeating decimal number. And also the sixth one, it is also a non-terminating, not repeating decimal number. So the third one and sixth one will be a irrational numbers. And see that fourth one, non-terminating repeating decimal numbers, 7.48 bar, it is a rational number. Then the fifth one is the number of decimal digits are countable, hence it can be represented in the form of p by q. so it is considered as rational number. So I am going to write this. Now we go for second bit. And the second bit, then what is the second bit of this 1.2? This is very important bit. We should be able to identify. If they are given one number, we have to identify either it is a rational number or irrational number. So we have to follow the properties. Give 4 examples of rational and irrational number. Give 4 examples of rational number and irrational numbers. So rational numbers. Rational numbers. 4 examples he asked. Let me write any numbers. 2 by 3, it is in the form of p by q. You can write any number. 4 by 7, this is a rational number. Then 2 negative rational numbers I will write. Minus 5 by 2, this is a negative rational number. Then fourth one, minus 2 whole 1 by 2. It is also a rational number. How can I say? It can be represented now minus. See, same thing. If I write here minus 3 whole to the power of 1 by 2, then you can write 2 3s are 6 plus 1 7 minus 7 by 2. See, 2 positive rational numbers, 2 negative rational numbers I wrote. It will be a rational number. Or not, I can also write the other example like a 0, also a rational number. Why 0 is a rational number? 0 can also be written as a 0 by 1. Yes. Now, the second one, the next 4 examples of irrational numbers. What are called irrational numbers? See, different examples will give you. Root 2 is an irrational number because root 2 value we cannot know directly. Then second one, non-terminating, non-repeating decimal numbers. Suppose 4.73256 and so on. No any decimal digits are repeating there and number of decimal digits are uncountable. So it is an irrational number. Then third one, pi is an irrational number. Pi is a Greek alphabet. Okay. 5 is a Greek alphabet. Here it is also will be considered as a irrational number only. Okay. Then fourth one. Then we write one more example of fourth one. Suppose you write any number like which cannot be written in the form of p by q. So we write square root of or not. Cube root of 8. Cube root of 8, it is a rational number. Sorry, cube root of 8 is a rational number. Cube root of 7, it is a irrational number because 7 cannot be written as product of 3 same numbers. So it is a irrational number. See, square root number, not perfect square root number, not perfect cube root number. 1 pi is an irrational number, 1 non-terminating, not repeating decimal numbers. These all are examples of irrational numbers. 4 examples we have written. This is what they are asked to write. So we have completed. Next, you can write any examples, not only this. To understand you, for example, I wrote as my wish. You can write any numbers which are for rational and for irrational numbers here. Just 4 they asked. Then third question. Then the third question is that, yes, now find an irrational number between 5 by 7 and 7 by 9. How many more there may be? Find an irrational number between 5 by 7 and 7 by 9. The given numbers are 5 by 7 and 7 by 9. 7 by 9. How many? So write one irrational number for this. How many irrational numbers you can able to write? So there will be 2 kinds of methods I will give you. 2 methods I will give you. You write any one method. That's enough. Okay. Let me go for the 2 methods. 5 by 7. Okay. Here A equal to you assume like a 5 by 7. B equal to you assume like a B. You take as a 7 by 9. Okay. Then here under root of AB method you can use. Under root of AB method you can use for the irrational numbers. Here under root of A, B, that means as I told under root of A is nothing but 5 by 7 into it is 7 by 9. See 7 7 get cancelled, as we can write here under root of 5 by 9. 5 by 9 is an irrational number. See root 5 by root 9. How can you say it is an irrational number? Let me write now. So it is under root of 5 by 9. No, it can be written as C. This will divide this root for numerator and denominator. Numerator is root 5 and denominator is root 9. It can be written as C. Root 5 is an irrational number by this root 9 value is 3. Root 5 by 3 is root 5 by 3 is a rational number or irrational number? Definitely it is an irrational number because it is in the form of P by Q, but P comma Q should be a rational number, but here root 5 is not, sorry, P comma Q should be an integer numbers, but root 5 is not an integer, it is an irrational number, so it can be considered as a irrational number. Now we can write the therefore first A, that is 5 by 7, which is less than, between these two we are finding, no, this is less than root 5 by 3, root 5 by 3, and which is less than 7 by 9. Only one we used, only is said to write one, only one a rational number is said, so only I got it 1. Then if you go for another method, you can also take this is A and B and you continue like that, if we get infinity many rational numbers also. Then we go for that. The other one, see 5 by 7, 5 by 7 equal to what? Let us divide the 5 by 7. This 5 will divide by 7. In rough work you do it, then you will get understand. Here we have to need some space actually to write. Here 5 we have to divide by 7. See 0.0 we have to put, because in 7 table 5 won't come, so 0. If you put 0 here, then 7 7s are 49 you can write, then 1 carry. Already we kept a decimal point, now we can keep one more 0 here. 7 1s are 7, we get 3, nothing but 30. 7 4s are 28, we get 2, nothing but a 20. Now 7 2s are 14, we get 6. Yes. Now again nothing but a 60. 7 8s are 56, we get 4, nothing but a 40. Now 7 5s are 35, we get 5. 5 is nothing but a 50 again. 5 is nothing but a 50. So see, now 7 7s are 49, 1 carry, nothing but a 0 again. Now 7 1s are 7, we get 3. It will be repeats like, see, now 3 is nothing but a 30, 7 4s are 28, we get 2. That means these decimal digits are repeating, you see. The same thing will be repeats. So we can write 5 by 7 equal to 0.71428 okay, bar like that. It will be continuous like that. Same digits will be repeats. Okay, this is what. Then now, what is 7 by 9? We don't require this much of division, but I told this is a like this. So it will be repeats like this. Now, then we go for 7 by 9. This, let me rub this now. Yes. Now let me write this 7 I will divide by 9. 7 I will divide by 9. 0.0 I can keep. 9 8s are 72. 9 8s are 72 or 8 9s are 72. Then 72 is not possible, no. 9 7s it is possible. So 9 7s are 63. 9 7s are 63. So 7 left, nothing but 70 again. 9 7s are 63. Again 7 left. Again 9 7s are 63. It will continue the same, no. So we write 7 by 9 is nothing but 0.777 and so on. So instead of taking here all the digits, let's take after the decimal point we take only two digits. After the decimal point we only take 2 digits. Okay. Let us consider. Let us take only 2 digits after the decimal point. After decimal point. Okay, then 5 by 7 equal to what? 5 by 7 equal to 0.71. Okay, then 7 by 9 equal to what? That is 0.77. See now. Okay, it will be continuous, but it will be continuous. But we takes only two digits now. What happens now? See, 5 by 7 equal to 0.71. Here 0.77. 71, nothing but a 77. You assume like a 71 and 77. 71, 77. Between that, 72 will be there, 73 will be there, 74, 75. There will be nothing more. No. So we write that now. Here we write 0.71 and so on, which is less than 0.72. You write here, or not 73. You write 74. You write 75 or 76. Any one number you write and put like an infinitive is less than 0.77 and so on. Finish no? This will be now 0.72 as an irrational number because number of decimal digits will be there. Okay. Now see, it is an irrational number only. There will be, you can write any decimal numbers here. Any decimal numbers you write, it will be a irrational number. This value will be like a 5 by 7. Now the question will be given in the fractional form. So we write like this, and this you write the same. 0.71, 72, 5, 6, 7, 5, 4, 3. You write infinitive decimal numbers are not limit like that. Infinitive. Here this value will be like 7 by 9. Yes. Either if you feel this is easy, you go for this, or not. If you feel this is an easy one, you can go for this one. You can go for any one of the method. Both methods will be valid. No problem. Or not? Yes. Now we go for fourth bridge. Yes. Now we go for fourth question. Find two irrational numbers between 0.7 and 0.77. Same kind of question as I explained here. Fourth question. Same question, children. Okay. Find two irrational numbers between the given numbers are the given numbers are what are the numbers they have given? Tell me. 0.7 and 0.77. These two are the rational numbers. We can write infinitely many irrational numbers. But see how I am going to modify this. 0.7 and 0.77. This I will write 0.7. I can write as a 0.70. That means after this 7, if you put number of zeros also, there is no use. There is no change also. So it can be written as 0.70, 0.77, 70, 77. Like that you just read 70, 77. Between 70 and 77. Should not read like a 70 and 77. It should be read like 0.70, 0.77. But to make you understand, I am reading 0.70, 77. 70, 77. Between that we have many infinitive, many numbers like a 71, 72, 73, 74, 75, 76. But we require only to know. Let me write 0.70, which is less than 0.71. We need irrational numbers. Remember, infinitive rational decimal digits. Infinitive decimal digits. You write any decimal digits here, no problem. Which is less than 0.72, 71, 72, and so on, which is less than 0.77. You finish that. Here 1, here 1. Two irrational numbers I wrote. Why these are irrational numbers? See, after the decimal point, the number of digits are uncountable, and the digits are repeating here. No, we don't know what are the digits are here. Infinitive I said. You can write 5, 6, 8. Not repeating decimal numbers, you can write like that. So these are the examples. Directly it will be a therefore. It will be a therefore for this. So now we'll be having the fifth question. Let's go for the fifth question now. I hope you understood. How I have written 0.7, I rewritten like a 0.70. Here 0.77, 70, 77. Between there is 71, 72. Or else you can write here 73, 74, 5, 6. Any number you write. It will be between 70 and 77 only, no? 70 and 77, between 75, 76, 71, 72, 73, 74. You write any two numbers. But don't forget to put the dots like that, infinitive number of dots. That will tell us it is a non-terminating decimal number, hence it is a irrational number. Then, fifth question. Listen this very carefully. Find the value of root 5 up to 3 decimal places. Find the value of root 5 up to 3 decimal places. Up to 3 decimal places, find the value of root 5. Root 5 value you need to find. Okay, it is very easy. How many places? Up to 3 decimal places. So, see here how I am going to do it. First, we have to make it like this. How many up to 3 decimal places is it? So, 5 point. Take 3 pair of zeros. 1, 2, 3. 3 pair of zeros you take. Because up to 3 decimal places is it. So, make it a pair. Finished? Now, see that this kind of division we have done in the 6th chapter in the 8th class. Okay, the same kind of division we are going to do it. Now see that here there is a 5. There is a number less than 5 which are perfect square number. Okay, which can be written as product of two same numbers. Nothing but a 4. This 4 can be written as product of two same numbers, that is 2 into 2 is 4. So the same 2 you write here. Here you do addition, here you do the subtraction. 5 minus 4 is 1. Here do the addition, 2 plus 2 is 4, very carefully. Here we have to write a number, but the number should come by multiplying two same numbers. Multiplying by same number, 2 into 2, 4. You can also write 3 into 3, 9. But what happens, this 9 will be greater than 5. We cannot subtract like that. So, remember. So, the same 2 you write here. So, do the addition this side, do the subtraction this side. So, same thing we are going to do it this side now. Now, 5 minus 4 is 1. To bring down these two digits, two pair of zeros, this decimal point we have to shift it here. Then you can bring down these two pair of zeros, that become a 100 now. Now see that what number you will write here. Suppose if you write 1 here, you have to write the same number 1 here. You have to multiply with the same number. Whatever number you write, the same number you have to write here, and the same number will be shifted here. That will be a quotient. See, 41 into 1, 41 will get. But here there is a 100, no? We have to take very nearest number to the 100. Now you can use 2, 2. See, 2, 2s are 4. 2, 4s are 8. 84 will come. Here positive, here negative. That means here plus, here minus. The same number you write here, 2. And do it. If you take 3 and 3, it will be more than 100. That's why I did not take 3 and 3 here. So 2 plus 2, 4. Here this 4, 44 it is. Now here we get 100 minus 84 is 16. See what I said? Now this pair of zeros you have to bring it down. It is a 1600. Now tell me that what number can be used here? See, if you use 2 and 2, we get only 2 2s are 4, 2 8s are, sorry, 2 4s are 8, 2 4s are 8. 884 you will get. But if you take a 3 and 3, it will be sufficient, because if you take 4 and 4, 4 and 4 1600, 4 into 400 1600, but here 43 also there, it will be crosses 1700 also. So 3 is a possibility here. 3 into 3 that is a 9, 3 4s are 12, 1 carry, 3 4s are 12 plus 1 30. Then here plus, here is a minus, but same 3 will be shifted to here. Then do the subtraction, here addition, 3 plus 3 6, 4 and 4. 443 plus 3, 446. Here it become a 9 and this become a 10 and it become a 5. We have borrowed 1. So 10 minus 9 is 1, 9 minus 2 is 7, 5 minus 3 is 2, 1 minus 1 is 0. That one need to write. Now let's go for one more pair of 0 we require, we get this. Now if it is take, see it is a 4. If you write here is 4 and 4, 4 4 is 16, that means 16,000 will come. Like that we have to estimate. If you take 5 4s are 20, that means 20,000 or 22,000, like that similarly we get. But if you use 6 for the 24. 24 plus this 400 into 6, 24. It will get 26, around 26. That means it will be a possible number. So we have to estimate which number can be used or which number is satisfies here. So add it here and subtract here. But when multiply once, 6 6 the 36, 3 carry. 6 is the 36 plus 3, 39, 3 carry. 6 4 the 24 plus 2, 27, 2 carry. 6 4 the 24 plus 2, 26. We got this. Now here it become a 9. Here it become a 10 and become a 0 now. 10 minus 6 is 4. 9 minus 9 0. And here it become a 6. It become a 10. 10 minus 7 is 3. 304. But the same 6 we have to do it here. Only up to 3 decimal places is set. So up to 3 decimal places. Therefore root 5 value is 2.236. The 2.236. Remember. Root 5 value is 2.236. Then we have to find out the value of root 7 up to 6 decimal places by long division method. This is called a long division method. Now we have to find out root 7 value up to 6 decimal places. Up to 6 decimal places. So what we have to do it? As I told you, same. This you have to go 7.123456 7. So 1 2 3 4 5 6. 6 pair of zeros we have to take. 6 pair of zeros. Then let me, if I tell this completely as like this, it will take a lot of time. So I will write directly the answer. You can see the answer and verify. You do by yourself once. Now here you can see the root 7 value up to 6 decimal places. 1 2 3 4 5 6. That is 2.645751. Here up to 6 decimal places. You just, before watching this one, just try it in the notebook and do it. If at all you don't get, you practice this. It is your homework problem, but I have done it here to check your answer. Okay, now we go for the next question. Next question, sir, that is locate root 10 on number line. So here locating root 10 on the number line, or locating root 2, root 3, root 5. How to locate the irrational numbers on the number line? How to locate the irrational numbers on the number line? This already have a done video, because geometrical instruments are required for this. With the using a compass only we can do it. Compass and scale we can do this. The question number 7 can we do it by using compass and scale. So already I have used geometrical instruments. With the geometrical instruments I have done a constructions. Then how to locate the root 2 is a irrational number, no? How to locate the root 2, root 3, root 5, root 10, root 8. This all I have explained in only one video. That separate video I have done. That video link I will keep in the description. You please go to the description and watch it. Or not, it will be in the 9th class only. It will be in the 9th class. After this exercise, you can see below in the playlist of 9th class, you can see the video that how to represent the irrational numbers on the number line. So the 7th question will not be explained here. This 7th question link will be there in the description. You can go there and watch it. 8th one, solution. Find the at least 2 irrational numbers between 2 and 3. Just before starting the video I told you, find at least 2 irrational numbers. The given numbers are The given numbers are 2 and 3. At least 2 irrational numbers is said. He said that to find out at least 2 irrational numbers. So it can be written as 2 and 3. Very easy method I will tell you. So this 2 can be written as root 4 and this 3 can be written as root 9. Root 4 value is 2, root 9 value is 3. Between root 4 and root 9 there are some irrational numbers. Let me write now. Root 4 which is less than root 5. This is less than root 6, this is less than root 7, and this is less than root 8, is less than root 9. See, we written 1, 2, 3, 4. We written 4, but he has only 2. So let us write now. Therefore, we have to write. You select any 2 from this and put it. Here itself, it will be answer. or not, but we have to write between 2 and 3. No, root 4 value we will rewrite like a 2 only. Now I will write only root 5 is less than root 6. Only 2 I will write because he said to write only 2. So root 9 value directly I will write as a 3. So between 2 and 3. Between 2 and 3 there is a 2 irrational number, that is 5 and 6 I wrote. You can also write 7 and 8, no problem. Okay, then ninth bit. Okay, ninth bit. Say whether they are true or false. These are the true or false questions. So if I go on writing on the board, it will take a time. So I will tell you either the statement is true or false. And also I will tell you why they are false. If there is a why they are true. I will also say the reason. You have to write the given statement is true or false. If it is true, you write true. If it is false, you write false. Then write the reason behind after that. Okay, let me go for the first question. Every irrational number is a real number. Every irrational number is a real number. Yes, this is a true statement. First question is true statement. Every irrational number is a real number. Because real number in the sense a set of rational numbers and irrational numbers are called as a real numbers. You have to write the reason. It is a true statement. Then put a heading reason and write a set of rational numbers and irrational numbers are called real numbers. Then second one, every rational number is a real number. Yes, it is also correct. True statement, second one also. The same reason will follow. The set of rational numbers and irrational numbers are called real numbers. The set of rational numbers and irrational numbers are called real numbers. Every rational number is a real number. Every irrational number also a real number. Real number in the sense there is a group of rational numbers and irrational numbers. So first and second statements are true. The reason is only same. The set of rational numbers and irrational numbers are called real numbers. The third one, every real number need not be a rational number. Yes, every real number need not to be a rational number. Yes, it is also a true statement. Every real number, how can you say it is a rational number? So it is also a true statement because a real number in the sense it will be a rational number and irrational number. This both will call as a real number. This both will call as a real number. Then every real number is a rational number? No. There will be a real numbers which are irrational also. So given statement is correct. Every real number need not to be a rational number. Every real number is need not to be only a rational number. There will be irrational numbers also. So the given statement is true. Write the reason that every real number is not only a rational number. There are some real numbers which are irrational also. Every real number is not only rational number. There are some real numbers which are irrational also. Irrational also. Then we go for root n is not a irrational number. Root n is not a irrational number when n is perfect square. Yes. Root n is not a irrational number when n is a perfect square. You write a perfect square. Root 4. Root 9, root 6, these are not irrational numbers when n is a perfect square number. These are perfect square numbers, right? Root 4 value 2, root 9 value 3, root 4 value 16. This all can be written as root 2 by 1 when these all are rational numbers. But he said the correct. Root n is not a irrational. It's not a irrational. Yes, it is a rational. It's not a irrational when n is a perfect square number. So the given statement is true statement. The given statement is true statement. The reason is that you can write this. You type n equal to under root of 4, under root of 9, under root of 16. Their values are 2, 3, 4. We can write by 1. These numbers are rational numbers. Yes, the given statement is true. Reason, root n is not a irrational number when n is a perfect square. You can write the same. Then fifth one, root n is a irrational when n is a not perfect square. Yes, it is also true statement. That it is also a true statement. Root n is a irrational number when n is a not perfect square number. Not perfect square numbers you take root 2, root 3, root 5. These all are not perfect square numbers. Yes, these are cannot be written as root 2 by 1, root 2, root 3 by 1, root 5 by 1. They are irrational numbers only. Yes, the given statement is true. The given statement is true. Root n is an irrational number. Root n is an irrational number when n is not perfect square number. Then we go for sixth one. All real numbers are irrational. All real numbers are irrational. All real numbers are only irrational? No. It is a false statement. Only one false statement is there. That is last one, sixth one. Remaining all five are true statements only. All real numbers are not only irrational numbers. So given statement is false. Write the reason. All real numbers are not only irrational numbers. All real numbers are not only irrational numbers. There are some real numbers which are rational also. There are some real numbers which are rational also. You write the reason properly, children. Okay. I hope you understood this exercise number 1.2. The seventh question you need to observe. That video link will be in the description. Thank you for watching. Thank you all.